Hello everyone, welcome to this lecture. We will explore today a few more example of methane rearrangement, which is a very important topic from photochemistry of organic compound. See this example. Here is a phenyl ring. In this phenyl ring, this double bond rotates, so this can become here. This double bond, pi bond become the part of this carbon-carbon double bond, and you can have this one pi bond, and this is a methane type structure. When we irradiate this molecule, this first of all this bond undergo homolysis. There is a formation of such radicals. Now there is this pi bond which is part of ring and which provides aromaticity, and so next breakage will takes place through hydrogen migration. In such case, so this hydrogen, one of these two hydrogen from this sp3 carbon undergo homolysis, and this one H migration takes place. 1,2 migration, we can say 1,2 migration. So this H transferred this carbon, and there is a generation of free radical on this benzylic carbon, and this bond, this dot, there is a formation of this cyclopropane ring, and this pi bond of this dipi system remain as it. This is the product which form this reaction. Let us take such moiety. So we have taken 3 phenyl and propene, 1 2 3 3 3 3 triphenyl propene. You can take phenyl here also, no problem. So what will be the product? So same method will be there, and but you see in this case, in the before this example, there is a alpha benzylic hydrogen, but here if there is no benzylic hydrogen, then how the procedure or mechanism will take place? You see here again there is a breakage of this bond after the absorption of radiation from UV visible range. There is a formation of now radicals, and after the radical formation, now what is the next? Which bond are going to break? There is no chance of hydrogen migration as we have seen in this last example, because there is no hydrogen here. Therefore this bond will undergo homolysis, and then again there is a formation of radicals, and then there is a formation of cyclopropane type ring here at this, you can see. And once it is formed, now there are two chances of breakage of bond. Either this bond will break or this bond will break. We know this bond will undergo breaking because to store the aromaticity, and therefore this bond will break and aromaticity will restore, and the radical from this carbon and this carbon, this rotate this side, and there is a formation of bond, and this is the product here. So we can write the product in this one. So two phenyls are there. This 3 phenyls are there. So what will happen here? So all 3 phenyls are attached to this carbon, but here 2 phenyls get separated from this carbon. This is the product. So we can write here the product in this reaction like this one, and that's all. Okay. Sorry. Okay, fine. Let us explore for next go for next example. This question asks in many times, 2 3 times in CSR exam. So this is a situation. This is the moiety, and you can see this is sp3 carbon, and this is a dipi system. Here also you can see there are 2 possible dipi system, 1 and 2. We can take only, or let us take this one, and let us irradiate this with radiation. So there is a formation of radical here. One more bond. This bond will undergo irradiation, and there is a formation of this after the breakage formation. Now this bond will form cyclopropane ring, we can say this, and this will form cyclopropane ring here, and this radical remain as it is. Now once it is formed, now the 2 bond on one of these two, one undergo breakage. Suppose this bond is undergoing a breakage according to the mechanism of dipymethane. So this radical and this radical will form bond. This radical remain here and this radical remain here. There is a formation of bond here, you can see. And when we open this structure, so this is the product you can observe after the rearrangement of this particular system in this reaction, you can see. Let us go for one more example. See here, suppose this is the system which is called as dipi system, and undergo same breakage of this bond and this bond also. There is a formation of this bond here. These 2 radicals would be remain as it is. Now which bond will break now? That is a very important question, you can see. this bond or this bond. Now see, if this bond is going to break, this bond is going to break. So here this radical is stabilized by a phenyl ring. So always remember, whenever there are chances of stabilization of the radical, so that side bond never undergo breakage. So this bond undergo breakage like this, and this bond, this dot and this dot will form bond, and there is a dot on this carbon, and that will come this side, and there is a formation of this side, formation of bond, and like this, that this product will form in this reaction. Okay, let us go for this is the not the diapymethane. It's a call, we can call it the oxa diapymethane, oxa diapymethane rearrangement example. So if you see here, so carbonyl is there. So when it absorbs the energy, there is a breakage of this bond, and radical will form. Again there is a breakage. There is a formation of cyclopropane ring. And always remember, in such examples, ketone will be restored. So always remember, in cyclopropane the bond will undergo breakage, which is going to form the carbonyl regeneration here. So this will break, and there is a formation of carbonyl, and this radical will form the cyclopropane ring, and there is a product. Let us go for the one more example here. See, again this is a oxidipymethane complex rearrangement reaction. Similarly, again this bond will break, and this bond will break, formation of cyclopropane ring. This dot will be there. Always remember, in this bond, in this cyclopropane ring, that bond will break, which regenerate the carbonyl. So this is that bond, and therefore this is the product will form. So let us go for the one more last example in this case. Here, see, if you see, this is the this such material will always present in the natural products. So again, this is the oxidipymethane rearrangement reaction. So if you see this on radiation, this bond will break, and this is the radicals. These are the radical will form, and further this will break, and there is a formation of a cyclopropane ring here. And we know this bond is going to break. Why? Because always we know that side bond will break, which gives the carbonyl regeneration, and this is the product will form in this reaction. So these are the few examples for diapymethane rearrangement reaction. In the next video we will discuss more examples of photochemistry. Thank you.